Just a little update video on my recent activities. Well, to be honest with you, I've been a bit selfish because most of my video has been going on live stream just recently. Well, if you haven't checked my live stream account out, you probably should, because sometimes I just live stream and I just, don't get around to uploading onto YouTube, and sometimes videos get lost, sometimes they get too big. And I kind of think, well, I don't think anyone wants to watch 1 hour or 2 hours of me prattling about. So anyway, this is a short YouTube video. So I recently designed this circuit board. Well, this is the schematic. I think I'm overdue to make an explanation. But basically, the output is split into two outputs, so that it actually sends alternating signals to two separate actuation coils from my device I'm sort of developing, right? Well, the outputs are split so that the back EMF is sent back through the capacitors like C8 and C9. So any back EMF spikes when the coil is collapsing is basically shunted back into the input, and it actually helps to assist the other coil, which is just being turned on. So when one coil is collapsing, the other coil has been assisted by the back EMF, right? Anyway, it's basically a mixer. So I'm using two frequencies going in. The driver transistors are simply driving two output stages, which is push-pull. So I've got my in this normal configuration, you would get a short circuit if it wasn't done properly, because the voltage from the emitter of the PNP would be going to the base, and it would short out if it was going directly to the base of the NPN emitter. But because of the way this works, the actual mixer circuit, which is in the middle, mixer driver circuit, is actually isolating that from happening, because the collector of another NPN is switching on the PNP, and that emitter is going to the drain or source of a 555 timer, which actually pulls down the voltage on the primary waveform. And a secondary waveform is also being brought in on another set of diodes, and that other circuit, the other voltage comes in, basically goes through the base of the NPN transistor, or VC192L. Anyway, I don't know waffle on about this too much, but basically I've got this circuit which I designed, and this is the board which I've built, so it's a bit clustered right now. But anyway, I made two of these boards. Here's another board without a lot of wires stuck in it, and the only difference between this board and the other board is the fact that the other board, this one down here, has got an extra two presets, which is down there for adjusting the duty cycle. Well, this one is easy to show you because it's not attached to anything, so I can actually show you this one. Well, basically it's simply a push-pull circuit, and I built this to drive my Bubbleator, which is down here, because there's two actuation coils on there. I've actually been balanced it with some magnets, some small magnets, just to help to balance things out of it. And I found out by putting some small button magnets around the laminations and the actuation coils, I can actually get my my actual voltage, which on the secondary is actually quite small right now, but I've got it up to 0.930 volts AC, and which is not bad considering I got very, very loose coupling. I haven't got many laminations running through. They're only like 2 millimeters by 3 millimeters. So the laminations, well, there's two on each group. So where that magnet is, there's the lamination there is actually 2 millimeters by 3 millimeters square. You know, well, 2 millimeters thick by about, well, it's actually 1.8 millimeters. Actually, it's not quite 2 and it's 3mm deep, so long, you know. So anyway, I've got 6 of those group pairs on this side. I have another 6 pairs on this side, and they intersect in the middle, and they're intersecting in such a way, like when you put your fingers from both your hands, and you know, you put your fingers from one hand in between the fingers of the other hand, the laminations are basically grouped like that. So anyway, but the output is very small, it's not much, it's just to test some ideas on overcoming Lenz's law and all this, but at the moment, well, we're making some progress, but it's slow, you know. It would help an awful lot, though, if people could send donations, because, I mean, this is costing me quite a lot of money to buy and get 3D prints made, and there's the components, and yeah, it helps a bit. And obviously I'm doing this open source, so I mean, I'm not actually keeping all this to myself, so I'm not doing any NDAs or anything. It's all open to anybody, so anything I find out, I'm sharing with people. So anyway, the voltage at the moment is just under a volt, actually, just a fraction under a volt. The current actually on there is only about 10 milliamps at the moment, because let's just try that out, put that on the current range. I need to move this probe over to current. Just a minute, I'll move that over because I can't do it while I'm holding the phone. Right, we're on the current now, and we're on the 400 milliamp range, and we're about 9 milliamps anyway. It's about 9 milliamps, it's thereabouts, I mean. So anyway, we're not at a lot, but it's the process of improving the circuit and design. And anyway, I'll just stick this back on the volts range. I have to move my probe up again. Sorry about this. It's hard to do this with one hand. Okay, so anyway, just a little update on what things happening right now. And here's one of the other boards I made. I haven't actually built this one. It's the same as what I've just been showing you, the circuit board. This is the printed copper side, which I haven't actually etched this one because I had a little error with it. There was a little glitch on the track. It was a bit messy, and plus I wanted to add the duty cycle, so I decided not to build this one. I drilled it though, but I decided not to build it because I wanted duty cycle on there as well, which I added to this one down here. So that is basic. This is my design, which I did myself, and the layout, and I also did the silk screen. So if you want to go check out my earlier videos on YouTube, you'll see how I did the silk screening, which is actually, the writing is very, very tiny, as you can see, but you can actually read that if you put the magnifying glass on. So with the magnifying glass on, let's see, the lens is a bit, magnifying glass is a bit mucky, but there's the writing, and very tiny. If you can see on my finger, you can see how small that is. And it came out really well. Anyway, thanks for watching.